Hello, and thank you for joining me. In this video, I am going to walk through solving problem 1 from my list of hard problems at sqlshortreads.com. For the hard difficulty problems within my learning portal at sqlshortreads.com and those you face on other learning platforms and even in interviews, I recommend translating each prompt or business problem into a data problem as you read the prompt by extracting the key pieces of information. Let's do that now. The Human Resource Department is concerned that recent associate turnover is largely attributed to dissatisfaction with salary. The first step HR wishes to take is to raise all employee salaries that are less than the midpoint of the salary range corresponding to the employee's job. They've asked you to generate a report that contains only those employees meeting this condition. The previous two sentences are critical to solving this problem. The report should only contain those employees with salaries less than the midpoint of the salary range for their job. A means to filter those employees is required. Continuing the prompt from where we left off, the necessary context required for the report is the employee ID, employee first name, employee last name, hire date, job title, current salary, minimum salary for the job, maximum salary for the job, and the new salary. The new salary should be the salary required to bring the employee's salary to the midpoint value for the job. In addition, HR has asked, if possible, include the percent increase based on the old salary and the new salary for each employee meeting the conditions of the report. Sort the report by percent increase, descending. The remainder of the prompt informed us on the attributes required for the report and the preferred sorting method. Now let us begin tackling the problem by taking the key pieces of information we extracted from the prompt and translate those into a data answer. To begin, I'm going to switch over to livesql.oracle.com where the objects and data already exist for this problem and many of the other problems on this page. If this is your first time tackling one of my practice problems, then I highly recommend reading the Getting Started section at the top of this page. Okay, let's start off with what we already know. We know that there are two tables required to solve this problem. The HR.employees table, so the employees table within the HR schema, and the jobs table within the HR schema. Let's run both of these to better understand their contents. This first output is going to be the employees table. Notice we have an employee ID, first name, last name, email, phone number, hire date, job ID, salary, commission percentage, manager ID, and department ID. I know immediately based on the prompt that we don't need all of these. In fact, we only need the employee ID, so I'm going to go ahead and do this. We need the employee ID, we need the first name, we need the last name, we need the hire date, we need the salary, and we also need the job title. But what I'm willing to bet is if we switch over to the jobs table, we're going to be able to use this job ID to look up that job title. So this serves as a foreign key. If I run the query against the jobs table, we're correct, right? So the job ID is the primary key. It's a foreign key in the employees table. We can use that to look up the corresponding job title for each employee. And this table also has the minimum and maximum salary. We definitely need these values. So what I'm going to go ahead and do is I'm going to go ahead and min salary, max salary, and I believe those are all the columns we need that are pre-existing. So these are the pre-existing attributes in each of these tables. Now, what I'm going to do is I'm going to go ahead and fully qualify each of these. So these come from the employees table, these come from the jobs table. And I'm going to actually have to join this, right? So we know that we need the job title, and that job title attribute exists in the jobs table. It doesn't exist in the employees table, but the foreign key does, right? So this primary key exists as a foreign key in the employees table, so we can use that fact to join these two tables together to get, for each employee, their corresponding job title defined by the job ID value. So what we'll do is we'll do an inner join to hr.jobs. And let's just do that. And then I'm going to do on. And how are we going to join these two tables together? We're going to join it based on the job ID. So again, the job ID attribute exists as a primary key in the jobs table and exists as a foreign key in the employees table for lookup purposes. So I'm going to say hr.employees.jobid is equal to hr.jobs.jobid. And if I've not made any typos, we should be able to run this and get what we expect. So we expect for each employee there to be one row and to get the corresponding attributes that we retrieve. So we said I need the first name, last name, hire date, salary, minimum salary, and maximum salary. But the thing that I missed out here is we actually need to add the job ID in here, or sorry, the job title, right? Because that's one of the required columns. And that was the whole purpose of the join. If we didn't need the job title or the min and max salary, then this join is not very useful unless we needed it for filtering purposes. Okay. So we have the attributes that we need that are pre-existing, right? So these attributes, when I say pre-existing, these are the attributes that already exist in the table. We don't need to do any formula or anything like that to create these or derive these in any way. They are already there. What we do need that we're missing is the new salary and the percent increase. So if we go back to the prompt, the new salary should be the salary required to bring the employee salary to the midpoint for the job, midpoint value for the job. So how do we get midpoint, right? So how do we get the midpoint for the job? Let's go back to the jobs table. And the midpoint for each job can be defined as the minimum salary plus the maximum salary divided by 2. So that's just finding the middle point between two numbers. And we're using these because we want the employee salary to be brought to the midpoint of this range here, right? So we want to bring each employee that is not having a salary or does not have a salary of at least the midpoint to be brought to that midpoint. So let's just test this out, right? So let's just do hr.jobs.star, and then I'm going to do hr.jobs.minsalary plus hr.jobs.maxsalary. Divide that by 2. Let's say as new salary. I'm going to run just this statement here. You'll notice this is the midpoint now, right? So this is going to be the result of taking this value for each row, the value within this column for each row and the value within this column for each row. So adding those two and dividing by 2. So 20,080 plus 40,000 divided by 2 is 30,040. And it's going to do that for each row. And this is effectively the new salary that we want to bring every employee to for the corresponding job that it isn't at least at that midpoint. So again, going back, this is where we're getting that. We're saying we're implementing this new attribute based on these instructions here. So the first step the HR wishes to take is to raise all employee salaries that are less than the midpoint of the salary range corresponding to the employee's job. So for any employee that is, say, an accountant that makes less than this, we're going to bring them to this value. That's going to be their new salary. So what we can do is we can effectively just take this, right? So we can take what we worked on in the jobs table in this simple query here. We're going to add it to our select clause. And I'm going to put that here. And what we'll do is we'll remove that and we'll run this again. And we'll get the new salary. So we haven't done anything wrong here. So this may stick out to you as, well, why would we want to do this for this person? Well, we don't. That's the whole purpose of this problem, right? We would need to determine how to do this only for the employees that don't meet the condition of having a salary that is less than the midpoint. And that midpoint is this, right? So this person, so William Yeats, does not make less than the midpoint. So we're not going to change this person's salary. But this person, for example, so Jennifer Whalen, she makes $4,400 and the midpoint is 4,500. So effectively what we want to do is we expect to see Jennifer Whalen in our result set with a new salary of 4,500. So what I'm going to do here is, instead of computing the percent increase first, I'm just going to go ahead and get this filtering criteria out of the way. How might we do this? So if we're trying to translate this into a filtering condition or some type of predicate, so raise all the employee salaries that are less than the midpoint. We can put this in the join, or we put it in a where clause. Either way, it's not going to make a difference here in this case. So how about we do that? We're simply going to do this. Right, if this is indeed the midpoint, which it is, we only want to retrieve those employees that make less than the midpoint, because that's who this initiative is going to impact. So those employees that we're trying to bring up to the midpoint for the salary range for that job. So what I can do is I can either do and I can say HR.employees.salary is less than the new salary, so the proposed new salary. You'll notice that we have Jennifer Whalen, and her new salary is going to be 4,500 like we saw previously. But what you're going to notice in this output, it's been reduced to 80 rows, and every employee in this output meets the condition of meeting less or making less, so their salary is less than the midpoint of the salary range for the job. So for example, Shelly's current salary is 12,008. The midpoint is 12,100. And that's what we want to bring her up to. Same thing with Jennifer. We want to bring her up to this from this. We want to bring Stephen King from this to this, and so forth. So this, by implementing this condition here, we're only retrieving the employees for which we want to actually raise their salary as part of this initiative. And like I mentioned earlier, this doesn't have to go here. You could technically, in this example, do it here, and you're going to get the same output. No difference. I'm going to keep it here for now. And our last step is we got to tackle the percent increase problem. So in addition, HR has asked, if possible, include the percent increase based on the old salary and the new salary for each employee meeting the conditions of the report. And the easy part here is to sort the report and percent increase descending. We first have to determine how do we calculate percent increase. So the way we can do that is a very common formula. It's going to be, let's do new minus old. So new minus old divided by old, right? And then we can multiply that by 100. So we can take something like this, multiply by 100 to determine the percent increase or decrease, depending on, in this case, it's always going to be an increase, right? Because we're bringing employees up to a higher salary, which is defined as the midpoint for that job. So how are we going to replace these? What are we going to do to actually change this from pseudocode that says new minus old divided by old times 100? Well, we're just going to plug in the corresponding values. So new, so we know the new is going to be this. Right, so our new salary is this. What I'm going to do so these parentheses don't get in my way and confuse me at the beginning, I'm going to remove them real quick. So the new salary is this. And what we're going to do is we're going to subtract that from the current salary. So new minus old. So new here, this is the new salary that we defined here. We're going to subtract that. So I'm just going to go subtract. And I'm going to say hr.employees.salary. Again, this is the salary, the current salary of the employee. And we're going to divide that by the old. So I will divide this. And we'll put that here. And then we're going to multiply by 100, right? Because we want this in a percent. We'll say as percent increase. And what I need to do here is I just need to fix up these parentheses. So I need to make sure that I perform this division first. So I'm going to put this here, divide, then I'm going to subtract, and I want that to also take place before I divide here. So I'm going to put one more here, one more here. Make sure I did this right. So 1, 1, 2, I need to make sure that this actually computes correctly, so we'll have that. This is out of place. I need to have an additional one here. And then that's correct. So I need one more. And let's go ahead and execute this. So again, this is our new salary minus the old salary divided by the old salary times 100. So new minus old divided by old times 100. So let's go ahead and run this. And we see our percent increase. So for Shelly Higgins, her salary is $12,008. The midpoint is $12,100, and that's what we're going to bring her up to. And the percent increase for that is less than 1%, so 0.7661 and so forth. Now, we haven't finished yet because we have to meet this last condition. That is perhaps the easiest part of this entire problem. That's to sort the report by percent increase descending. What we'll do is we'll just add an order by clause. And we're going to say percent increase descending. Run that. And now we have successfully generated this report that contains one row per employee for each of those employees that meet the condition of having a salary that is less than the midpoint for that corresponding job. So again, the midpoint is defined as the middle point between the minimum salary and the maximum salary. So 2008 plus 5,000 divided by 2. That's going to be the 3,504. We're going to bring the employee salary, so TJ's salary, from 2,100 to 3,504, resulting in a 66.86% increase. And that's it. If you enjoyed this video, then please like the video and subscribe to my channel for notifications on future videos. Thank you again, and see you next time.